All right, now that we've seen how to build and use a board view inside a playground, I want to demonstrate to you that we can use a similar approach to build the model and the whole game logic inside a playground as well. And the way how I did this is by essentially implementing a struct that is called board up here that will serve as the model for my application and at the same time implements the logic for a tic-tac-toe game. So let me show you how this works. And in fact, the whole implementation of this board can now be used to play a tic-tac-toe game because it contains all the logic, except that we don't really have a user interface, but we can play a text-based version of tic-tac-toe right here in the playground. The first thing that I need to do for this is to instantiate a board. And I just use the default initializer in this case. I don't need to provide any information to the board upon initialization. All right, the board actually has a property that is called current turn. And this current turn indicates whose turn it is at the moment in the game. So the default value for the player who starts with the game is cross. And now the board has a method that I can call, and that is called move. And I only have to pass in an x and a y coordinate for this method to work. And in fact, the player who's going to make the move right now will be the cross. So it would, of course, also be possible to pass in the player, so either cross or circle, into the move function. But actually, by removing this parameter from the public API of the board, I make sure that a player cannot make two moves in a row. So I prevent this kind of requirement for the tic-tac-toe game by not giving a caller of the move function the option to pass in the player, but rather the board itself keeps track of whose turn it is at the moment and will make sure that this player will actually make the move when I'm calling the move method here. So let's start with cross and let's make it a move in the middle. If I now call current turn again, we actually have to make the board a variable rather than a constant because I'm mutating the board, I'm changing its internal state. So now after we've made the first move that was made by cross, we now see that the current turn is now circle. Let me actually write this as a no. All right, so if we make another move now, and let's take a move for circle at this coordinate, we'll see again that the current turn has been changed and cross's turn is again. The board also has a winner function that I can call that is going to tell me whether we have already a winner. So this winner function will examine all the previous moves, and based on these moves it will determine whether one of the two players already won the game or not. And in case where we don't have a winner yet because no player managed to get 3 in a row, well, the function just returns nil. So let me actually go and finish this game. So let's make another move with x at the coordinate 0, 0. Then we'll make another move with O at coordinates 2, 1, let's say. The winner in this case still returns nil. But if I now go ahead and make the final move with x and place it at 2, 2 so that we get the whole diagonal row, we see that the winner function now returns cross.